I'm Dr. Petra Szilágyi, and I'm a lecturer in functional materials. I've been at Queen Mary for about 2.5 years, and beforehand I lived and worked at a number of places, including Australia, the Netherlands, Scotland, France, and Hungary, with some shorter stays in the US and Japan. I actually graduated as a chemist, but I did my degree, a PhD degree in physics as well. So I have also worked at various departments, ranging from pure chemistry through chemical engineering and material science all the way to physics, which just shows you how interrelated these disciplines are. I was also sort of too much of a chemist for the physicists and too much of a physicist for the chemist. So I'm actually very happy to be just be qualified as a material scientist and named as such. And so I do teach students in material science as well as in chemical engineering. And I teach them mostly chemistry-related subjects, such as chemistry of materials and materials processing, as well as fundamental processes such as how the transformation of one phase to another, such as like the melting of ice, for example, or mixing of two substances can be described physically as well as quantified.
So what are your research interests?
So I'm very passionate about sustainability. So my research is focused on energy conversion and storage, which is admittedly a very, very broad area. And my group focuses on working with one particular type of material called metal organic frameworks. And these are a type of hybrid inorganic organic material based off, built up of different building blocks. And their representatives are typically highly crystalline and very porous as well. So we take advantage of this. It means that the pores within these structures are very well determined in both in terms of geometry as well as in chemistry. So this is what we use. So what we do is we introduce gas materials inside these pores, and these gas materials can be sort of ionic compounds, they can be molecular compounds, they can be even metal nanoparticles. And what we are doing is we are engineering the interactions of these gas materials with the host framework, with the pores of the host framework, so the strengths of these interactions, which in turn, what it's going to do, it's going to modulate the properties of these guest materials as well as potentially of the host framework. So we're using this sort of interface for applications in energy conversion and storage. And that includes, so some examples are battery technologies, fuel cells, so such as, for example, the ones you would use in a hydrogen car, as well as for catalysis. And these materials are often very expensive, and also they're manufactured, or when you can manufacture them, but typically they're synthesized in a quite sort of under quite harsh conditions. So that means it's very environmentally unfriendly. So my group also focuses on developing new technologies to synthesize these materials in a greener and more sustainable way. So in a sense, we're trying to use sort of sustainable processes of making materials that then can be used for sustainability applications.
What is your biggest achievement?
So I have recently obtained the Women's Engineering Society's top 50 women engineers in sustainability award. So that is obviously a biggie. I should probably also mention that I previously got the Media Fellowship of the British Science Association for my public outreach activities. But I suppose I'm proudest when some of my group members, such as my postgraduate or undergraduate students, either achieve something. It can be either some very good results, but particularly, but because they work really hard, to be honest, and if their work is recognized and awarded, that I'm that's when I'm proudest and the happiest. For example, recently, James, who's one of my PhD students, he got a research excellence award at the symposium. So, yeah, these are achievements I really sort of cherish and very proud of.
What kind of different things have you been involved in during your career?
Okay. This is quite broad, I suppose. But so for research, for example, well, I first started as a nuclear scientist. So, and sort of gradually moved into sustainability. So this is quite a journey that I have made. And but I suppose there was always sort of something underpinning this, which was how external conditions may modulate the properties of materials. So such as the temperature, the pressure, and such like. So I've always been very interested in that. And I have also mentioned that I've kind of lived in quite a few places beforehand. So when I first moved abroad, that was a hugely eye-opening experience. And I suppose this kind of made me more resilient as well. But what I enjoy the most is attending conferences and visiting collaborators and exchanging ideas and debating and sort of, yeah, bouncing around ideas, really. And so this took me really quite a few places, including countries such as South Africa, Morocco, China, Thailand, Indonesia, and Vietnam. And what is, I think, is quite exciting is that in some of these countries, some areas in these countries are truly off-grid. So, and I think there is a huge opportunity to build up a fully renewable and sustainable energy infrastructure from scratch, rather than having to sort of patch up and modify the existing infrastructure. So I think this is a really exciting opportunity, and I'm really hoping that I will be able to contribute to that.
Is there any advice you would give to a student thinking about studying either material science or chemical engineering?
So I suppose the most important thing, and possibly it's not just in material science or chemical engineering, but in general, is that you should really do what you love. So you find your passion to something, and in my experience, your performance will be best when you're the happiest. So you have to experiment. You have to see what really motivates you, what really inspires you, and just continue. And one very important thing is that there will always be things that go wrong. This is how science and technology is. So you just come up with an idea, you try to prove it, or you try to realize it, and then it's going to turn out to be, well, hopefully not a disaster, but something completely different from what you expected. And this is obviously disappointing, but this happens all the time. So it's very important to realize that it's not just you. This happens to everyone. And I think you can get strength from this sort of community in that this happens to everyone. And I think for this reason, it's in any case, it was very helpful for me, but I think it is in general helpful to try to build your little supporting network as soon as you can. This can be your family, even better if it's your peers, so fellow students or PhDs, postdocs, but even more senior members. It can be your supervisor. Hopefully you will have a good enough relationship with them, but you can also have a mentor that can help you through this, because they will you will be able to see that difficulties you're experiencing, that other people face them as well, or they have faced them as well. So you're not alone. And maybe they won't be able to give you the best advice how to get out of it, but I think the very idea of not being alone or is already helpful. So yeah, I think this is important. But yeah, try to think of what is the thing you truly care about and just go for it.
Great. Thank you, Petra.
Thank you, Vicky.